Hi, my name is Christina Clements, and this is our submission for the VISSOFT challenge. Our project focuses on visualizing bug life cycles within the Debian operating system, which uses the Linux kernel. In order to analyze these bugs specifically, we first had to collect our dataset directly from the Debian database, which houses a bug tracking system. The system contains the bug reports, messages, and other information used by developers. And we use the filters of the database to narrow down our dataset into bugs that have been both reported and marked as fixed at the time of our dataset collection. We did this to be able to visualize their duration and any changes in their duration over time, as well as other insights included in the bug reports. And after further inspection of this data set, we did realize that 11 of our dates were incorrect due to an archive error, and therefore we did have to redo our visualizations. However, we were able to improve them and create them with a little more information involving severity level. So in this first graph, you see that there's a high concentration of data in the first 200 days of the bugs being fixed. So we wanted to look closer at that specifically. So within the 200 days, we also separated out the categories of severity to see what bugs were being prioritized. And we can see there's a high concentration of serious, grave, and important bugs as compared to other ranges later on, which is very important to note as they are prioritizing the more serious bugs. And then we can see a line graph of the yearly reported versus fixed bugs, and there is a large increase in both reported and fixed bugs in the last 3 years. This does show a large sign of growth in the system overall, and there is a large number of bugs being fixed over bugs being reported, which does show a sign of bug management efficiency and improvement in that area, which is a very positive sign for developers to note that they are fixing bugs faster and creating a smoother process and system. So within the severity and duration, we wanted to separate these out to look closer at each severity level. So the wish list items do have the widest range, while the serious and grave have the lowest, which is expected because these do tend to need to be fixed quicker in order to have the system working as it should. And then the normal important were fixed at a fairly average rate. But we can see this also does have the highest concentration of bugs just by number. So our next graph is the top 10 packages by number of bug reports, and we can see one of the highest affected packages is the source Linux folder, which does make sense as it is one of the main files of the system. And many of the other files would be affected, especially when making changes and edits. So just making sure that we maybe do a little more testing on this specific package before we release new versions or updates, just to minimize the amount of bugs for that file. And then for our last one, we have our bug report duration over time and including their severity as well. So we are able to look at this data set from 2000 to 2025. However, I do think that it is helpful to be able to zoom in on specific dates and get better insight on the more concentrated areas, just because it can be kind of hard to see when when the dates are so far apart, and it's kind of hard to see the details of specific months. So we can also separate them by severity. So if we just want to look at the serious, grave, and important bugs, we can see there's a high concentration of them. However, they are being fixed fast and being fixed faster as they are being reported later on. So I just thought that this was an interesting piece to add into our graph to add a whole nother level of insights into how the durations are changing over time. So I thank you very much, and thank you for your time.